In this video, we're going to look at the differences between acidic, basic, and neutral solutions. So first we will look at neutral. What is a neutral solution? A neutral solution is defined as having equal hydrogen ion and hydroxide ion concentrations. An acidic solution is defined as having a greater hydrogen ion concentration than hydroxide ion concentration, and this makes sense when you consider the definition of an acid, being a proton donor, the Bronsted-Lowry definition, or even if you look at the Arrhenius definition, which is that an acid releases hydrogen ions. And a basic solution is one in which the hydroxide ion concentration is greater than the hydrogen ion concentration. In the Arrhenius definition of bases, bases are defined as substances that release hydroxide. In the Bronsted-Lowry definition, bases are proton acceptors, and when you study weak bases, you will see how they produce hydroxide ions. If a neutral solution has equal concentrations of hydrogen ion and hydroxide ion, we could represent them both with X and use the Kw value to actually calculate them. 1 times 10 to the negative 14th will equal x squared, and x will equal 1 times 10 to the negative 7th. That is both the hydrogen ion concentration and the hydroxide ion concentration. That gives us a pH of 7 for a neutral solution. But be careful, this is only at 25 degrees Celsius, because that is the temperature for this value of K. If the temperature changes and Kw changes, the pH of a neutral solution will also change. Because an acidic solution has more H plus present than OH minus, at 25 degrees Celsius, we have an acidic solution with an H plus greater than 1 times 10 to the negative 7th molar, which gives us a pH of less than 7. And a basic solution at 25 degrees Celsius will have less H plus and a pH greater than 7. Now let's consider a different temperature where we have a different value for Kw. If we're still talking about a neutral solution, we will have equal amounts of H plus and OH minus. So once again we set up our Kw equals H plus times OH minus, and when we solve for x we get 2.1 times 10 to the negative 7th. This is the H plus concentration, and it is the OH minus concentration. Taking the negative log of this number gives us a pH of 6.67. So at this temperature, with this value of Kw, this is the pH of a neutral solution. Anything acidic will have a pH lower than this, and anything basic will have a pH that is higher.